Alright, today we're going to prove a fact. That is, a triangle with vertices at lattice points cannot be regular. That is, it cannot be an equilateral triangle. Now, what is the lattice point? Of course, in a 2D plane, that would be the integer coordinate. Like, for example, 0, 0, 3, 4, the x, y coordinate are integers, right? So we call this lattice point. If a triangle has vertices on the lattice point, then the triangle cannot be equilateral. How do we prove that? We're going to prove by contradiction. We're going to use two methods for the proof. Now, one basic fact we're going to use is about rationals. Usually capital Q letter represents a rational number, which are numbers that can be expressed as a quotient of or a fraction, P over Q. Of course, P, Q are integers and Q is non-zero. All right. So one important property is that rationals are closed under operation of typical arithmetics: add, minus, times, and divided by. All those operations, including, for example, absolute value, which is just either positive or negative of x, right? So all those operations are closed for rationals. So that is, if you add up two rationals, it still remains to be rationals. Okay, so this basic fact we're going to use now. One way to prove by contradiction is to look at the area of a triangle. Now, first we claim that even though we say this triangle has vertices on lattice point, it is okay to assume one of the points A is at position 0, 0. That's the origin of your coordinates, right? If not, you can always have the translation of the triangle so that one vertex is on the origin. All right. So with that assumption, B and C both have integer coordinates. That is, we have A, B, C, 3 points, and B and A, lowercase b and A, and x and y are integers. All right. So we want to prove that this triangle cannot be regular. Okay. Assume it is regular. All right. Let's look at the area. The area of triangle, if you know the 3 coordinates, is going to be half of this determinant, right? So, and with that, if you simplify that determinant, it's going to be by minus ax. Notice that we have integers. They're closed under operations, so this is rational. The area is a rational value. Now, however, if you assume a triangle is a regular triangle, we know that the regular triangle, the area, is related to the side length, right? If the side length here, AB is the side length here, right? AB is this is the length. The area of the triangle is square root of 3 over 4 times the square of the one side length, right? But what is AB here? If you use the distance formula, you know that would be a squared plus b squared, right? So what we have is some rational number and some rational number times square root of 3. We know that square root of 3 is irrational. They have to equal to each other because it's two ways of calculating the area, right? So we have this equation here, and then you can express square root of 3 in terms of a bunch of rationals which are closed under operation of add, minus, or square or fraction here, right? So which is a contradiction, right? Because we know the left-hand side is irrational, while the right-hand side is rational. So that's proof by contradiction through the area calculation. Now, the second method, we're going to use what is called the trigonometry here. Now, assume, of course, with this method, there's some special condition depending on the shape of the triangle. For example, they could be aligned with y-axis or x-axis, right? In other words, the C could be just vertical, right? And on the right, on the y-axis, right? So those special condition, you can prove that. We're going to skip that steps, okay? To be rigorous, however, you need to consider those special cases. Now here, I give you a hint. Here is when we look at the tangent alpha and tangent beta, that is kind of inclination angle of the two sides, AB and AC, right? So by definition here, so the tangent of alpha is going to be y coordinate here, which is A over B, and beta here is going to be y over x. That is, we have this fact. Notice that both are rational numbers because a, b, x, y are integers, right? So what is the difference of this beta minus alpha? That's exactly the triangle here, the angle A. If we assume is regular triangle, that would be 60 degree. Tangent 60 degree would be square root of 3. So we have tangent alpha and tangent beta are rationals, and beta minus alpha equal 60 degrees. So tangent of that would be square root of 3. Plug in the formula for the tangent, and you have on the right hand side rational numbers, because rational numbers are closed under minus, fraction, and plus, and times, right? So left hand side square root of 3 again is irrational. So that's a contradiction again. So proof by contradiction with two different approaches. Okay, hope you enjoy the problem. Please like, share, and subscribe to the channel.